Hello everyone, in this video we are going to learn a simple short trick to find the number of integral terms or rational term in any binomial expansion. This is a very easy shortcut and everyone can find the answer within seconds. So let's start. Short trick to find the number of integral terms or rational terms in the expansion of this type: a to the power of 1 by p plus b to the power of 1 by q whole to the power of n, where these two numbers a and b are prime numbers. If a and b are prime numbers, then quickly we can apply this formula. So before doing this question, make sure that these two numbers a and b both are prime numbers. If they are not prime numbers, we will convert them to prime numbers and then we will apply the formula. Therefore, the formula here is number of integral terms is equal to greatest integer function of, this is not just a bracket, this is greatest integer function of n divided by LCM of p and q plus 1, when if n is completely divisible by p or q. Okay, if this power n is completely divisible by p or q, then we can use the first formula, that is using n divided by LCM of p and q plus 1. We need to add plus 1 at last. But if n is not completely divisible by p or q, then we will use the second formula, greatest integer function of n by LCM of p and q. No need to add plus 1 here. Okay. So check the power is divisible by p or q. Then accordingly we will apply the formula. Let's do a question. Find the number of integral terms in the expansion of 5 to the power of 1 by 2 plus 7 raised to 1 by 8 whole to the power of 1024. To do this question, first check these two numbers. This is 5, this is 7. Both are prime numbers. So first condition has satisfied. So we can apply the formula. Now secondly, compare the equation and find the value of n. Here n is equal to 1024. So write n is equal to 1024. Now check the second condition and find out which formula to apply here, first formula or the second formula. If n is completely divisible by p or q, then we can apply first formula. Here the value of n is 1024. So check 1024 is divisible by p or q. Here p is equal to 2 and q is equal to 8. Write the values of a and b also. A is equal to 5 and b is equal to 7. And now you can see here 1024 is divisible by 2 and 1024 is divisible by 8. So we can apply the first formula here. Greatest integer function of n by LCM of p and q plus 1. Therefore, number of integral terms is equal to greatest integer function of, here n is 1024, so 1024 by LCM of p and q, that is p is 2, q is 8, 2 and 8 plus 1. Here we are adding plus 1 because n is completely divisible by 2 and 8. That's equal to greatest integer function of 1024 by LCM of 2 and 8 is 8 plus 1. Now cancel 1024 by 8, and that's equal to 1 time, then 2 times, then 8 times. 128 plus 1. That's equal to 129. Therefore, our answer, total number of integral terms or rational terms, is equal to 129. In this way, we can easily find the total number of integral terms in any binomial expansion. Let's do one more question. Find the number of integral terms in the expansion of 3 raised to 1 by 2 plus 5 raised to 1 by 8 whole raised to 256. Let's find out the answer using the same short trick. Here we can see the number 3 and 5 both are again prime numbers. So we can apply the formula here, and the power n is equal to 256. Compare and write the value of p and q. P is equal to 2 and q is equal to 8. In the question, the value of a and b are 3 and 5. Both are prime numbers here. So we can apply this formula. Number of integral terms is equal to This 256 is completely divisible by 2 and 8. So we can use the first formula itself, n by LCM of P and Q plus 1. That's equal to greatest integer function of, here n is 256. So 256 divided by LCM of P and Q is 2 and 8 plus 1. That's equal to LCM of 2 and 8 is 8 itself. So we can write greatest integer function of 256 by 8 plus 1. Now divide 256 by 8. That's equal to 256 by 8 means it is 3 times. Here it is 2 times. So 32. 32 plus 1 is equal to 33. Therefore, the total number of integral terms is equal to 33. Another question, find the number of integral terms in the expansion of 9 raised to 1 by 4 plus 8 raised to 1 by 6 whole raised to 500. Here we can see these two numbers 9 and 8 are not prime numbers. So our first step is to convert these two numbers into prime numbers and apply this formula. Here given numbers are 9 and 8. Both are not prime numbers. If both are prime numbers, then only we can use this formula. Here this number is 9 and this is 8. We can simplify both these two numbers. Therefore 9 raised to 1 by 4 plus 8 raised to 1 by 6 whole to the power 500 is equal to 9 means we can write it as 3 square. Therefore 3 square whole raised to 1 by 4 plus 8 means 2 raised to 3 whole raised to 1 by 6 whole to the power of 500. That's equal to 3 square whole raised to 1 by 4. That means we can write this as 3 raised to 2 by 4. That's equal to 3 raised to 1 by 2 plus 2 raised to 3 whole raised to 1 by 6. That is equal to 2 raised to 1 by 2 whole raised to same power 500. Now we converted this expression in this form with these two numbers 3 and 2 both are prime numbers. Therefore we can apply this short trick here. Number of integral terms is equal to n by LCM of P and Q plus 1. Here n is equal to 500 and the value of P is equal to 2 and Q is equal to 2. Just look at the power here, both are 2 here. Therefore P and Q is equal to 2 itself. This number 500 is completely divisible by 2. Therefore we can apply first formula itself. Number of integral terms is equal to greatest integer function of n by, that is 500 divided by LCM of P and Q, that is LCM of here P and Q both are 2. Therefore 2 plus 1, that's equal to 500 by 2 means it is 250. 250 plus 1 equal to 251. Therefore total number of integral terms is equal to 251. So in this way we can easily find the total number of integral terms in any binomial expansion within seconds.